All right, I think we can get started. So as always, welcome everyone. If you have any questions, you can ask in the chat. Lewis will be there helping me. So this is the fourth and last chapter of the course. Uh, this is a bit different to the previous three. In this one, we'll show you a bit more on how to use the platform and how to leverage all of the Hugging Face features. So this is the quick agenda for today. First, we'll see a bit about the platform, then we'll show you how to use existing pre-trained models, then how to push models to the hub, both with the push to hub method and the Hugging Face client command line interface. Then we'll talk a bit about model cards, and to close, we'll show you like some bonus content that is not part of the core of the course. So yeah, so the hub, the Hugging Face Hub, you've already used it a bit on the previous chapters. It's the central platform that enables anyone to discover, use, and contribute new state-of-the-art models and datasets. It hosts a wide variety of models, so it had more than 10,000 public available models. We can check right now how many it has. So right now it has 11,000 publicly available models for anyone to use. So the hub has support for both models and datasets. In this chapter, we focus completely on the model side of the hub. So the models in the hub are not limited to Hugging Face transformers, and it's not even limited to natural language processing. There are models from FLAIR and NLP for NLP. For speech, there is Asteroid and Pinode, and there is also TIM for vision. This is just to name a few. So if you want to see all of the supported models in the hub, so this is huggingface.co, you can go to resources, and here you can go to model hub doc. And at the left, you can look at libraries. And here we have the full list of supported libraries and how well supported they are, depending on the different features. So there's Hugging Face transformers, but there's also adapter transformers, LNNLP, Asteroid, ESP.NET, FLAIR, Pinode, sentence transformers, Spacey, TensorFlow TTS, and TIM. So each of these models is hosted as a Git repository. So if you've used GitHub before, this will be very straightforward to you. Sharing a model on the hub means opening it up to all the community. It makes the model accessible to anyone looking to easily use it. In turn, it will eliminate their need to train a model on their own, and it will simplify sharing and using the model. Additionally, the hub also has something called the inference API. So in the moment you upload a model to the hub, there will be an automatically deployed hosted inference API that allows you or anyone else in the community to try out the model directly on the website. So the video will show you a bit more of this, but just so you have an idea of what I'm talking about. I think we already did a bit of this in the first chapter, but if you open a repository, here at the right, you have a hosted inference API. So you can try this query, and if you click compute, this is a field mask model. It will predict what word should go there. So the goal of life is life. Okay, so that wasn't great, but you get the idea. And it's not limited to field mask. Actually, there are like a lot of other tasks. Okay, I will show you the first video of this chapter, but please feel free to ask anything in the chat if you have any questions.
In this video, we're going to go over the Hugging Face Model Hub navigation. This is the huggingface.co landing page. To access the Model Hub, click on the Models tab in the upper right corner. You should be facing this web interface, which can be split into several parts. On the left, you'll find categories, which you can use to tailor your model search. The first category is the tasks. Models on the hub may be used for a wide variety of tasks. These include natural language processing tasks, such as question answering or text classification, but it isn't only limited to NLP. Other tasks from other fields are also available, such as image classification for computer vision or automatic speech recognition for speech. The second category is the libraries. Models on the hub usually share one of three backbones: PyTorch, TensorFlow, or JAX. However, other backbones, such as Rust or Onyx, also exist. Finally, this tab can also be used to specify from which high-level framework the model comes. This includes transformers, but it isn't limited to it. The Model Hub is used to host a lot of different frameworks models, and we are actively looking to host other frameworks models. The third category is the Datasets tab. Selecting a dataset from this tab means filtering the models so that they were trained on that specific dataset. The fourth category is the Languages tab. Selecting a language from this tab means filtering the models so that they handle the language selected. Finally, the last category allows to choose the license with which the model is shared. On the right, you'll find the models available on the Model Hub. The models are ordered by downloads by default. When clicking on a model, you should be facing its model card. The model card contains information about the model, its description, intended use, limitations, and biases. It can also show code snippets on how to use the model, as well as any relevant information: training procedure, data processing, evaluation results, or copyrights. This information is crucial for the model to be used. The better crafted a model card is, the easier it will be for other users to leverage your model in their applications. On the right of the model card is the Inference API. This Inference API can be used to play with the model directly. Feel free to modify the text and click on Compute to see how would the model behave to your inputs. At the top of your screen lies the model tags. These include the model task as well as any other tag that is relevant to the categories we have just seen. The Files and Versions tab displays the architecture of the repository of that model. Here we can see all the files that define this model. You'll see all usual features of a Git repository, the branches available, the commit history, as well as the commit diff. 3 different buttons are available at the top of the model card. The first one shows how to use the Inference API programmatically. The second one shows how to train this model in SageMaker. And the last one shows how to load that model within the appropriate library. For BERT, this is transformers.
Okay, so I think that was quite straightforward. Maybe let me just briefly expand a bit on some points. So the UI changed a bit, but if you click now Deploy Accelerated Inference, you get this code snippet so you can make requests in Python. But this is not limited to Python. This is like a normal API call, so you can use JavaScript or whatever language you use. Then here at the right, if you click using transformers, you get this code snippet that you can use. But as we discussed before, this is not limited to transformers. So if you go to the models page, and at the left, you can click here the +19, and here you can see all of the supported libraries. So for example, if we go to sentence transformers, that will filter out all of the sentence transformers. And here, the code snippet will change. So for example, here the code snippet is specifically for this library. So that makes it very nice, like a very nice integration with other libraries. And if you click here, compute, this widget is for sentence similarity. So you get a source sentence and then destination sentences, and you will get the distance between the source sentence and each of the others. So how similar these are. So for this model, the closest thing to that is a happy person is that is a very happy person. So that makes sense. So there is a question, can we use a keyword-based search to search for models for a particular task? So if you are interested on a particular task, you can go to models and you can then click text generation, for example, and then here you can do like additional search. So for example, GPT. You can also have like additional filters, so for library, datasets, languages, but we are improving the search functionality now. So just stay tuned and there will be like nicer features for discoverability of the models. Good question though. Okay, so this was how to navigate the hub. Let's quickly discuss something that you will probably be already familiar since you did this in the first and second chapters. So let's say that we are interested on a French-based model that can perform mask filling. So yeah, let me remove this. So we said fill mask and you want French. So we can use this one, camembert base. Normally what you should do is read the description, the model card, to understand what this model is about and what's the purpose and if it has any biases, any limitations. We'll talk a bit more about this in a few minutes. Okay, so there are like three different ways of using the model. So the first one is like we did in the first chapter. So we use the pipeline. So this is like this super high level function. So from transformers import pipeline, you specify what's the task that we are solving, which is fill mask, and we specify the name camembert base. And as you can see here, we get a prediction. You can also use the specific model architecture to load the model. This is similar to what you did in the second chapter. So this is a camembert model. It has a camembert architecture. So you can import camembert tokenizer and the camembert for masked language model, and you can do this. Lewis showed you in one of the previous sessions, if you go to GitHub transformers source transformers models, you can see all of the architectures that are implemented in the transformers library. And as you can see, there are quite a bit. So what is normally suggested is to use the auto tokenizer and auto model, the auto classes, because these are architecture agnostic, and then you don't need to worry about what's the specific architecture. So let me just briefly step back to the pipeline, which I think is something important, is that you need to make sure that the model you're using, the checkpoint you're using, is for this task. So let's say that you want to use instead text classification. The model was not trained for this, so of course this will not make any sense. So it will give you an output, but it will complain. It will say that you probably need to train the model on a downstream task, as you did in chapter 3. And yeah, the prediction is pretty much meaningless here. Okay, so this was nothing new, but I think that what will be more interesting is the next section, which is how to share pre-trained models. So these are like the last two videos of the first part of the course. So the first one will show you how to manage a repo and how to upload files with a command line interface. And the second video will show you how to use the push to hub methods. So there are like three different ways of doing things. So one is the web interface, one is using the transformers or Hugging Face Hub command line interface, and the third option is the push to hub API. So let's jump to the video and remember to ask any questions in the chat.
In this video, we're going to understand how to manage a model repository on the Hugging Face Model Hub. In order to handle a repository, you should first have a Hugging Face account. A link to create a new account is available in the description. Once you're logged in, you can create a new repository by clicking on the New Model option. You should be facing a similar model to the following. In the Owner input, you can put either your own namespace or any of your organization's namespaces. The model name is the model identifier that will then be used to identify your model on the chosen namespace. And the final choice is between public and private. Public models are accessible by anyone. This is the recommended free option, as this makes your model easily accessible and shareable. The owners of your namespace are the only ones who can update and change your model. A more advanced option is the private option. In this case, only the owners of your namespace will have visibility over your model. Other users won't know it exists and will not be able to use it. Let's create a dummy model to play with. Once your model is created, comes the management of that model. 3 tabs are available to you. You're facing the first one, which is the model card page. This is the page you used to showcase your model to the world. We'll see how it can be completed in a bit. The second one is the files and versions. Your model itself is a Git repository. If you're unaware of what is a Git repository, you can think of it as a folder containing files which can be versioned. If you have never used Git before, we recommend looking at an introduction like the one provided in this video's description. The Git repository allows you to see the changes happening over time in this folder, hence the term versions. We'll see how to add files and versions in a bit. The final tab is the Settings tab, which allow you to manage your model's visibility and availability. Let's first start by adding files to the repository. Files can be added through the web interface thanks to the Add File button. The added files can be of any type, Python, JSON, text, you name it. Alongside your added file and its content, you should name your change or commit. Generally, adding files is simpler when using the command line. We'll showcase how to do this using Git. In addition to Git, we're using Git LFS, which stands for Git Large File Storage, in order to manage large model files. First, I make sure that both Git and Git LFS are correctly installed on my system. Links to install Git and Git LFS are provided in the video description. Then we can get to work by cloning the repository locally. We have a repository with a single file. The file that we have just added to the repository using the web interface. We can edit it to see the contents of this file and update these. It turns out I have a model handy that can be used for sentiment analysis. I'll simply copy over the contents to this folder. This includes the model weights, configuration file, and tokenizer to the repository. I can then track these files with the git add command. Then I commit the changes. I'm giving this commit the title of Add Model Weights and Configuration. Finally, I can push the new commit to the huggingface.co remote. When going back to the Files and Versions tab on the web interface, we can now see the newly added commit with the updated files. We have seen 2 ways of adding files to a repository here. A third way is explored in the video about the Push to Hub API. A link to this video is in the description. Unfortunately, the front page of our model is still very empty. Let's add a README markdown file to complete it a little bit. This README is known as the model card, and it's arguably as important as the model and tokenizer files in a model repository. It is the central definition of the model, ensuring reusability by fellow community members and reproducibility of results, and providing a platform on which other members may build their own artifacts. We'll only add a title and a small description here for simplicity's sake, but we encourage you to add information relevant to how was the model trained, its intended uses and limitations, as well as its identified and potential biases, evaluation results, and code samples on how should your model be used. Great work contributing a model to the Model Hub. This model can now be used in downstream libraries simply by specifying your model identifier.
Feel free to ask any questions in the chat. I am Holmes. You asked, so tokens only come into play if we are working with organizations. I guess you are referring to the authentication token. So normally when you log in your computer to Hugging Face with a Hugging Face command line interface, every user has a token that is saved locally. And then in the server, when you push files, the backend makes sure that you have access to specific files. So if you are a member of an organization and you push a model, or you create a repo or delete a repo in an organization, you will always need to, your token will be part of the request. But this is for any request because we need to know like which is the user making the request. Let me know if that wasn't a very clear explanation or if you were referring to another token and not the authentication token. Okay, so let me just show you the last video and then we'll do some coding if that sounds good. And in the meantime, feel free to ask any questions in the chat.
Let's have a look at the push-to-web API. Just before recording this video, I fine-tuned the BERT model onto the Glue MRPC dataset. We won't go over the fine-tuning code here, because you can find it in any Transformers tutorial or by looking at the videos linked below. What interests us here is what happens when the training is finished and we've got metrics we're happy about. This video requires you to 1. Sign up for an account on the huggingface.co website, and 2. Have your authentication token to that website stored, which can easily be done by typing Hugging Face CLI login into a terminal, or like this in a Colab notebook by using an exclamation mark. This command won't work if you're using a regular Jupyter notebook, so if you are using that and don't have access to a terminal, you'll need to copy your access token from the huggingface.co website into the training arguments. I'll show you where exactly in a little bit. With that done, the push-to-web API will allow us to upload to the Hugging Face hub our model, its configuration, and the associated tokenizer. To use it inside the trainer, you have to make sure to set push-to-web equal to inside the training argument. We can specify a model ID for a repository, which will default to the name of the output tier if we don't say anything. We can push to an organization, as long as we're a member of that organization, and this is where your Hugging Face token should be pasted if you need to. With all of this done, we can call trainer.pushToHub once the training is finished. In future developments, we'll add the ability to automatically push to the hub at the end of each epoch or every given number of steps, so stay tuned. The command returns a URL for a specific commit, which we'll be able to inspect if we copy it in our browser. Just before checking that, note that if you were not using the trainer API, you can directly push your model and your tokenizer to the hub by using the push-to-hub method. By passing the commit URL in my browser, I can access my repository, called fine-tuned-BERT MRPC, as expected, and see that several files have been added. A model card, the configuration of the model weight, the TensorBoard runs, and all the files required by the tokenizer. The trainer drafted a model card for us, which contained the final results on the evaluation set, the training hyperparameters, the intermediate training results, as well as the frameworks I was using. If I click Edit Model Card to see the raw content, I can see the trainer also generated a table of metadata that the Hugging Face Co website is going to use to properly apply filters to my model. I can also directly access the TensorBoard runs inside the Model Hub by clicking Training Metrics here. Now that the model is on the hub, we can use it from anywhere with the FromPretrain method. We just have to use the identifier from the hub, and we can see that the model configuration and weights are automatically downloaded. We can use this model as we would any Transformers model, for instance, by loading it in a pipeline. Since the MRPC dataset is a dataset of pairs of sentences, where the task is to determine if two sentences are paraphrases of one another or not, we use it on two sentences separated by step. It's a little bit disappointing to see that it's predicting label 0. That's because I didn't specify any label when I created the model configuration. Fixing this is super easy with the push-to-web API. First, we can fix the configuration locally by setting label to ID and ID to label. with a proper value. Then we can push the fixed config to our repo with the push to hub method. Once again, this returns the URL of a commit, which we could inspect and see the exact diff inside the config. And note that the command is going super fast because I'm using the same local folder as before, on which my repo is already cloned. Once this is done and we create a new pipeline, we can see the new configuration is automatically downloaded thanks to the built-in versioning system, and we get the new label. We can also play with the model directly on its model card. By pasting the text I was using and clicking Compute, I just have to wait a little bit of time before the model is loaded on the Inference API and displays the result. Once the model is loaded, we can double check we get the same results as before directly on the widget. Try the push to hub API on your models today.
All right. Yeah, going back to the question from IM Holmes about the authentication token. Now that I saw this example, I think that I understood a bit more where your question came from. So normally when you do Hugging Face CLI login, your authentication token will be stored in the cache, and then you won't need to do it ever again. But for example, if you're working in Colab or, yeah, I don't know, in an environment in which maybe you don't want to do login, instead you can specify and force a specific authentication token, and that's the use case of the auth token param. Okay, so let's do some coding. So you will need to do your configuration in Git if you are, yeah, your normal Git configuration. I already did login before, so I have a typo here. Who I am. Sorry, it's who am I? Yeah, there we go. So I already did login before starting this session. So my username is HackerTech. So I'll show you a few examples. So the nice thing about the push to hub API is that everything in Hugging Face in Transformers has this method. So models, tokenizers, yeah, you name it. So if you do this first 3 lines, it will push the model file and it will push the tokenizer file. What is very nice is that if you use the trainer API, okay, now I'm getting an error. So let me just quickly. Okay, this is new. Okay, let me try once more. In the meantime, let me show you an example of a repo uploaded with a trainer API that if you follow the PyTorch tutorial in chapter 3, you are quite familiar. So just by specifying push to hub, you will get a bunch of very nice things. So you will get a description, you will get the loss, accuracy, F1 or other metrics. You will get placeholder sections that you can later on complete. You will get all of the training hyperparameters that were used during training. You will get this nice table with the results during training for every epoch. And you will also get the framework versions. So this is very useful for reproducibility. On top of this, there is this very nice feature which is hosted TensorBoard in the hub. So if you have TensorBoard traces in your repository, and it's not limited just to Hugging Face transformers, like it can be like any TensorBoard traces, you will get automatically TensorBoard deployed for you. And here you will be able to look at the metrics. Okay, it seems like I still have problems for some reason. Sorry. So let me instead just do in the terminal. This will be easier. Yeah. So let's first import what we care about. So here we are just initializing a model and tokenizer as we've done before, so nothing new. Okay, it may take a bit. And then the idea is to just do model.push to hub and then the name of the repo. So let me just do it to Tommy. Yeah, it takes a few seconds. This command is uploading all of the model for you. I'm actually not sure why I got this error, because I tried it like 10 minutes before and I was not having this issue. Repository not found. Okay, this is taking, I think my computer is having a hard time with the live stream at the same time. In the meantime, like if you also want to specify an organization, you can do so. And as we were discussing before, you can also specify a token if you want. Okay, so another option is using the Hugging Face, I don't know, tokenizer, push to hub. Okay, so the repo was created automatically because it didn't exist. Let's see if the files, they are still being uploaded. Yeah, normally it doesn't take this long. I'm not sure if this is my computer or if there's any connection issue right now with Hugging Face. Okay, in the meantime, while that runs, let me show you like the second approach, which is using the Hugging Face CLI. So if you use Hugging Face CLI repo create dummy2, it normally creates a repo for you on the hub. Yeah, so it asks you, do you want to create repo hackertech dummy2? I say yes. And it gives you both the link to look at it on the browser, and it also tells you how to clone it. So this is similar to what Lisanne was making in the first video. Here you can do like the normal things. For example, you can create a model card, which is this normal markdown file. So this is a test. You can preview it, and you can commit. And when you commit, you get here like this is a test. This is what I wrote in the model card. You can look at all of the files. You can look at the history of the repository. Yeah, and as you can see here, I have this commit 14 seconds ago, in which I did this change. So this is like very nice because if you are used to GitHub workflows, you can use this to create branches, for example. You can also revert back changes very easily, so it has like very nice versioning. Okay, so going back to the previous one of the tokenizer, in which I use tokenizer.push2hub. If you go here to files and versions, you can see here that the files were uploaded now. Yeah. So let me just quickly check the history. Yeah, so I think that there was some connection error. As you can see, actually both the model and the tokenizer were uploaded, so that's good. So what the Hugging Face infrastructure normally does for transformers is that it analyzes the config JSON. The config JSON specifies a bit like what's the architecture, yeah, these kind of things. And based on this, it already tells you like this is a field mask model, it's a Camembert model, it's transformers, it's using PyTorch. This is all based on the files and the config. And you can already use here the hosted inference API. You will need to wait, especially the first time, you need to wait for the model to load on the backend. And you can even, like if you want to deploy, you can use this in the accelerated inference API and make as many calls you want. Yeah, and play around with the model, and you can very easily integrate this to your own products. Okay, yeah, so that was the push to hub. So, okay, so we going back to the command line interface, which was dummy 2, I think. Dummy 2, maybe. Yeah. So right now we don't have anything, right? We only created the model card. So let me now. Okay, it's my computer that is very slow. So what we can do now is like a normal GitHub workflow. You can do git clone and then the name of the repo. So now, for example, I already have the repo. It just downloaded the README, which is the only file. The git attributes is also there, but it's a hidden file, so you won't see it unless you specify also like the hidden files. So as Lisandro mentioned in the video, apart from Git, we also use Git LFS. That is Git large file storage. This is super useful for files that are very large, which is very common in machine learning. So this is for files that are larger than 10 megabytes. And normally what we do is that you can specify which extensions you want to handle with LFS. So yeah, all of this. So normally what you need to do is to do git LFS install just to make sure it's initialized. And yeah, let me show you a nice example. So let's say that we want to work with a model locally, maybe train it, and then instead of using the push to hub, we want to save it locally and then push. So that's what the save pre-train method is for. So let me just put the right name, which is dummy2. Let me now just copy paste all of this code snippet. So what this is, let me just explain line by line while it runs, is that it will, the same thing, we load the model, we load the tokenizer, then we save the model in the directory dummy2, which is where we clone the repo, and we also save the tokenizer. But as you can see, my computer is having a hard time with the live stream, so it's a bit slow. Sorry for that. Okay, it went well. So if you look at now dummy2, you can already see all of the files. So let's just enter the repository. And if you do git status, it's normal git, you will get like, okay, all of these files are to be added. They are not tracked right now. So if you do git add, this will add all of the files to be tracked. Then you can do git status, and you will get yeah, some things. Another thing you can do is git LFS status. This is nice because now you can see which files will be handled with normal Git and which files will be handled by Git large file storage. This is just like for additional info. It's not something that you need to worry too much about. You will need to worry if you have like a file with a new extension that is very large, but it's super easy to just add a new extension. So for example, you can just change the Git attributes. Anyways, let's commit my first model. So very easy, and then you just do git push. Since these are like very large files, normally it takes a bit. So I'll just keep moving a bit for now, and then show you. Okay, so this was pretty much everything for the sharing pre-trained models section. Let me just quickly, we already saw how to use the web interface. And this is what we just did, which is how to upload a file. Yeah. So as you can see, 80 something megabytes, that's why it's a bit slow, even with a relatively fast connection. Okay, so the last section is a bit different. It's about how to build a model card. So we already saw like few model cards. Just as a recap, the model card is this file, which is very important. It explains the model, it ensures that it's reusable by the rest of the community, and it provides a platform on which other members can build their artifacts. So documenting how the training and the evaluation was done helps others understand what to expect of a model, and it will also provide, and providing sufficient information regarding the data that was used and the pre-processing and post-processing that were done ensures that the limitations, biases, and context in which the model is not useful can be identified and understood. So if you upload a model without anything in the model card, no one will use it because they won't know what the model is for. Instead, if you have like a very nice model card explaining what it does, how it was trained, what's the purpose, what are the limitations, which are the biases, that will be super useful for other people. And additionally, as we'll see in 1 minute, you can add some special metadata that will make your model discoverable by the rest of the community. So as we saw, it's just a README file. And if you're more interested on this, the model card concept originates from a research direction from Google. The paper is called Model Cards for Model Reporting. That's by Margaret Mitchell et al. So there's a lot of very useful information contained in that paper. So we recommend you to take a look at it. There are some sections that we recommend: model description, intended uses and limitations, how to use, limitations and bias, training data, training procedure, and evaluation results. So these are not strict. We don't force any specific sections. So the model card really has a lot of flexibility. So here there's a paragraph explaining each of these sections. I think that you can go over it by yourself, but what might be more useful is to just quickly go through a very nice model card. So this is bird-based case. Probably you're already a bit bored of this repo at the time. We've seen this quite a bit. So it has like few sentences explaining the model, where it was introduced. Then it has a description of the model, explaining the high-level overview of the model, how it was trained, in which objectives, and what the model learns. So for example, the model learns an inner representation of the English language that can then be used to extract features, useful for downstream tasks. So it also has this intended uses and limitations section. So it tells you that you can use this for masked language modeling or next sentence prediction, but the intention of this model is to be fine-tuned on downstream tasks. You can also get here like a code snippet, although now the how to use section, if you're using transformers, you can also just click here using transformers and load it from here. Then it shows you how to do it in PyTorch and in TensorFlow. Here actually there's a bug here. This is for TensorFlow. It should be just BERT model, and here it should be TF BERT model. But anyways, you get the idea. Then there's a limitations and bias section, which is very useful. I think it's super important. So let's just read it. So even if the training data used for this model could be characterized as fairly neutral, this model can have biased predictions. And this is very similar to what we did at the end of the first chapter with the pipelines. So the man worked as a, and the predictions are lawyer, waiter, cop, detective, doctor. And as you can see, the woman worked as a nurse, waitress, maid. So as you can see, the model has some biases, and as it's mentioned here, and as we saw before, this bias will also affect all fine-tuned versions of this model. So it's important that if you pick a model, you need to understand the biases, because very likely those biases will probably transfer to your own model as well when you do when you do fine-tuning. It also explains what's the training data, how the training was done, what's the pre-processing, pre-training, a table of the evaluation results, and finally, how to cite it. The model cards are very flexible. Just let me quickly show you the metadata. So at the top, people can add useful metadata. So for example, you can specify what's the language, what's the license, what datasets were used when training the model. You can also add as many tags as you want, so then people can click here, expert, and they will find all of the models that have this tag. If you would like to learn a bit more about the metadata, you can go to resources, model hub doc. Then you can search here. We have a couple of sections on metadata, but this link in particular has an example of the model card and what's the structure. So which languages you have, the license, which tags you want to have. So for example, you can use this to specify third-party libraries or specific tasks, datasets, metrics, and also you can add specific metrics which can later on be processed by other pipelines. I think that's pretty much it. Feel free to ask any questions, and if not, I will show you. So this is the end of the chapter. There are two very small things I would like to show you, which are part of the Hugging Face hub. So the first one, let me just go out of this. If you have transformers installed, very likely you already have the Hugging Face hub installed. This is a client library that gives you access to a lot of things. So this is what allows anyone to push files to the hub. You can do a lot of very nice things. And if you would like to integrate this to your own code, it's very straightforward. Apart from having wrappers to upload things or download things from the hub, you also have access to information from the hub. So for example, if you would like to get all of the models that are for a specific library, this will return quite a bit. So this will return information, not the actual models. Let's say in field mask. I think that will be clearer. So this will make a call to the backend. This will return all of the information on all of the field mask models. And as you can see, there are 1,000 mask filling models on the hub. So let me just show you the first item. So as you can see, the model name is Albert-based V1. It gives you all of the tags, and it tells you what's the task this model, this repo is for. So there was a person from the community that was doing the course, and they decided to actually create a Hugging Face dataset of all of the models that are on the hub. So that's quite nice. So if you would like to do model exploration and more of that, that that's like a fun project that anyone could do already with this provided info. So if actually you would like to learn a bit more about this, the repository is Hugging Face Hub, and this is like the open source place for everything related to the hub. So you get a client library to download and publish on the hub. You get the inference API for third-party libraries. You get the widgets. So the widgets are the things at the right of the model in which the model card in which you could try the model directly on the web, and more things. So that's very nice. And this is a very recent feature. Let me first Hugging Face CLI create dummy 3. Okay, so I'm first creating a repo, and I need to specify repo before probably. Yeah. I am Holmes is asking if there is an option to search by the number of stars using the Hugging Face API. Maybe wait for next week. There will be some announcements on that, so please stay tuned as well. Yeah. So let me test this. So right now I created a repo, and let's say this is a context manager. So maybe let's first explain the code. So the Hugging Face Hub has this class which is repository, which allows you to clone a repository in a specific directory. So I just did dummy 3, if I'm not wrong, and it will clone from dummy 3. And this is a context manager, so you've probably done similar things with files. So you can do with repo.commit, my first file. Anything that you do now will be committed to the hub. So this is like a very nice wrapper that will probably make your life easier. Just let me quickly check that this will work. So we import, so this initializes the repository. So now you can do with repo.commit. So my first file with open file text, Okay, so this is this part, write, with open file as file, blah, blah, blah. This can be anything. Like this is not limited to text files. You can do anything that is writing. So you're probably very familiar with this. The only new thing is this wrapper with repo.commit my first file. And now if we go to the hub, so let's go to my profile. Here we have dummy 3. And if we go to files, we'll see that the file that I just created here with open file, blah, 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 is not actually done for locally. It's done to commit that to the repository. So this is like a nice way of handling file writing on the hub. And as you can see, the file is already here. Okay, so those two were like the two bonus things I wanted to show you. So this is like the last chapter, but we will have like some different activities going on in the next few weeks. We also have in the forum this share your projects section. So at this point, you already have all of the tools to fine-tuning, for example, of text classification on a specific task. So what you can do now is searching for an interesting data set in the hub. So here in the hub, you can go to datasets, and you can search there for interesting datasets, and you can work on creating a classification project, text classification project, and it's quite easy to share this. And feel free to comment here like, hey, I trained this with what I learned on the course. That would be awesome. We have one question, which is, so the advantage of the repo.commit context manager is that we don't need to do a git commit every time. Yeah, so this is like a easy programmatic way of handling everything with a context manager. It's mostly like a convenience wrapper. I hope that makes sense. All right. Do we have any other questions? Thanks, Ayama Holmes. All right, then thanks a lot for everyone that was able to join. Yeah, and see you in the forum.